A function is an assignment from one set of the domain to another set, called the range, such that each element in the domain is assigned to a unique element in the range. If this is the domain of f, then a function is assigning from the domain of f to the range of f. For example, here is an assignment that is a function. Why this is a function? Let's look at the restriction. Each element in the domain is assigned to a unique element in the range. Let's just write down the assignment. F of -2 is 4, f of 1 is 3, f of 2 is 0, and f of 5 is 4. We really have this restriction in this assignment, because each element in the domain, -2, 1, 2, and 5, are assigned to a unique element in the range. What about this one? I see that f of -2 equals f5 equals 4, but f is still a function, because this does not violate the condition that each element in the domain is assigned to a unique element in the range. Let's take another example. In order to check if this assignment is a function, we are going to again write down what is f of the elements, because there are very few elements in the domain of this function. F of -2 is 4, f of 1 is 3 and 2, and f of 2 is 0. F of 5 is 4. You can see that in this case f1 is assigned to 2 elements in the range, and that's why I can conclude that this assignment is not a function. As you can see, if you have this situation, the assignment is not a function. A graph of a function y equals fx is the set of all possible points xy such that x is in the domain of the function and y equals fx. Let's take a small example, fx equals x to the power of 2. It means that any point on the graph is exactly x for the x-coordinate, and y, the y-coordinate, is f of x, which is x to the power of 2. You are familiar with this graph. Obviously, this graph does not describe everything, because it is impossible to sketch a graph that contains all the numbers of the real line because of restriction of space. The domain in this case is the set of all real numbers. To test if a graph is a graph of a function, we apply the vertical line test. If a vertical line intersects the graph at most once, then the graph is a graph of a function. Example. Here's a vertical line. We have to go all over the graph with this line. And we can see immediately that this is a graph of a function. Let's again apply the vertical line now on this one. You can see immediately that this is not a graph of a function. A function is even if f of -x equals fx to all x's in the domain. In this case, the graph is symmetric about the y-axis. Here's a good example. You're familiar with this function. This is fx equals x to the power of 2, and to any x in the domain, which is any x, which is a real number because the domain of this function is all R, we get that f of -x equals negative x to the power of 2, which equals x to the power of 2, which happens to be f of x. So if you look at this line, you can see the beginning f of negative x, and then you see that this really equals f of x. A function is odd if f of negative x equals negative of fx to all x's in the domain. In this case, the graph of an odd function is symmetric about the origin. And here's a nice example. This is the graph of the function fx equals x cubed. Let's really do the algebra here. You substitute negative x for x in the function, and we will get that f of negative x is negative x cubed, which is a negative times x cubed, which is negative fx. Most of the functions that we will see in calculus are neither odd nor even. A small shift of an even or odd function can just destroy this property. Here's an example. Y equals x to the power of 2 is an even function. Y equals x minus 1 to the power of 2 is already not an even function. One-to-one functions. If a function is such that f of x1 does not equal to f of x2, where x1 does not equal to x2, then the function is called a one-to-one function. To test if a graph is a graph of one-to-one function, we apply the horizontal line test in addition to the vertical line test. If any horizontal line intersects the graph at most once, then the graph is a graph of a one-to-one function. Here's an example. First of all, we are applying the vertical line test, and this is a graph of a function. Now let's apply the horizontal line test, and you can see that this function is not one-to-one. This example, vertical line test. This is a graph of a function. Now let's apply the horizontal line test. This function is one-to-one. The reason I'm applying also the vertical line test in addition to the horizontal line test is because a one-to-one function first of all has to be a function.